When will it start? Good evening, students. Am I audible to all? Kindly let me know in the chat. Students, am I audible to all? Okay, fine. Just give me a minute. We'll start in a minute. Before beginning, I would like to tell you that we have pinned the WhatsApp group. So everybody, whoever is interested to join for further updates for any kind of further online sessions, you can please join the WhatsApp group. And as we are seeing those live courses over here, same way we have different courses available in V2V classes also, which are paid courses. So you can please go for them. For further details, you can contact the owners, or you can join the WhatsApp group, which will be giving you all the records. So if the screen is visible, shall we start, everyone? Okay, so today we'll be solving the next question paper, that is of summer 2019. So I hope that from the previous class you have got better inputs and now you are able to solve the problems in a better way, right? So I begin with the solutions. Successor. Okay, what is a successor? See, simple thing, I'll just explain here. देखिए, अगर एक ट्री, मैं अगर एक ट्री यहां पे डिजाइन करती हूं, इस तरह से, नाउ अगर आप देखेंगे, सो दिस इज द पेरेंट एंड दिस इज द चाइल्ड. सो द चाइल्ड इज द सक्सेसर ऑफ द पेरेंट. अगर मैं आपको बोलूं फाइंड आउट द सक्सेसर ऑफ ए, यानी इन शॉर्ट सक्सेसर मीन्स यू हैव टू फाइंड आउट द चाइल्ड. सो सक्सेसर ऑफ ए आर बी एंड सी. व्हाट इज द सक्सेसर ऑफ बी? नथिंग, इट्स नील, सिंस बी का कोई चाइल्ड है ही नहीं, सो देर इज नो सेंस ऑफ अ सक्सेसर ऑफ बी. सेम वे सक्सेसर ऑफ सी, it's nil because there is no child of C. In reverse order, if I ask you to find out what is the predecessor, so predecessor का meaning ये होता है which is the parent. So if I ask you to find out what is the predecessor of A, this is going to be nil because there is no parent of A. A is the root node. When I am saying predecessor of B, so predecessor of B is A because A is the parent of B. Same way predecessor of C is A, which means that A is the parent of C. This is what is a simple logic of successor and predecessor. Am I clear to everyone? Okay, so I will quickly move on to the summer 19 question paper. So I'll be now not wasting time in explaining you each and every question. Rather, I'll slightly move faster because we have two question papers to be solved, right? So I'll go to the question number 6A, Ninad. Just give me some while because I have to run through all the questions. So I'm beginning now. List any 4 operations on data structure. So what are the different operations? Now the question says, 4 operations. So remember, each operation will give you half marks. So total 4 operations will give you complete 2 marks. So what are the different operations mentioned? Insertion, deletion, searching, sorting, traversing, merging. You can use any 4 operations which will give you complete 2 marks, right? Enlist the queue operations to enlist queue operation conditions. Okay, so whenever you are going for any queue, there are basic operations which you need to do. That is, to have to check whether the queue is full or the queue is empty, right? So this is what are the different types of queue operations, right? So that you can mention to each operation will give you 1 mark. And this is enlist. So whenever it is enlist, students, you have to just write down. आपको सिर्फ लिखना है, list down करना है, आपको कुछ भी explain नहीं करना है whenever the question is enlist. Okay. Moving ahead, define what is a binary tree and a binary search tree, difference between them. So we have already discussed that binary tree will have maximum 2 children. Okay, so this is in short. So if I say this, so this is a binary tree. Now, if I'm saying 15 and I'm saying 25 and I'm saying 30, this is a binary tree, right? So here I'm not following any rule like left subchild will be less and right subchild will be higher, not in that way. So as a result of that, this is your simple binary tree. Whereas if I'm going for a binary search tree, we abbreviate it as a BST. So BST के लिए rule होगा इस तरह से. जैसे your left child will be less, your right child will be higher. If this condition is satisfied, it is a binary search tree. Otherwise, it's going to be a binary tree. Okay. Moving further. Is this understood to all of you, difference between binary tree and a binary search tree? Okay, fine. See, question number 4D, when I go in the sequence, I will let you know what it is. If it is wrong, we will correct it over here, right? So question number 4D, we will see in the sequence. Expression tree, everyone please note over here. Now, if I am saying I want to write what is the proper definition of what? Atharva, if you can please clarify your doubt. Of what you are asking the definition. Okay, up to the time Atharva answers me, we'll go for the expression tree. Now let's say I am telling you to go for this expression. Let's say a plus b plus, or I'll just represent this by into a plus b into c plus d. Okay, so what does this mean? If I am going to represent in an expression tree, आपको क्या याद रखना है? Operators will be nodes. Operators are going to be nodes. तो ये आपका एक नोड है, ये आपका एक नोड है. ओके, आपका जो ऑपरेटर है दैट इज गोइंग टू बी द पेरेंट नोड, और आपका चाइल्ड नोड्स विल बी योर द ऑपरेंड्स. ओके, उसके बाद वैसे ही आप यहाँ पे C एंड D ले सकते हो. ऑपरेटर आपका जो प्लस है, दिस प्लस विल कम इन बिटवीन C एंड D. एंड ये दोनों के ऑपरेशंस क्या है? दिस इज कंप्लीटली, आई एम सॉरी, this is completely multiplication, right? So this is how we design an expression tree. So simply अगर एक expression दिया है, उसको इन फॉर्मेट में रिप्रेजेंट करना है जहां पे आपका जो भी ऑपरेटर होगा that's going to be your root node, and आपके ऑपरेंड्स जो होंगे they are going to be the leaf nodes. That is what is an expression tree. Is this complete? Is this understood, everyone? Kindly let me know before I go ahead. Okay, taking a harder expression. Let's say 2b plus 5 into 6c plus 9. Okay, in this way. Now, if you take this expression, check, you have something known as 2b. So, 2b is 2 into b. Am I right? This is 2 into b. This plus 5 is this plus and 5. Okay. Same way here, if I say 6 into c. This is plus and 9. And then this entire thing is compared to a multiplication. This is how you write an expression tree. Now is it understood, everyone? Okay, fine. So the question from Atharva, binary tree and binary search tree. See, definition of binary tree simply can be any tree which has maximum 2 children. Any tree which has maximum 2 children. Now there is no restriction. Restriction नहीं है कि वो children कैसे होने चाहिए, whether it should be less or it should be higher. ऐसा कोई restriction नहीं है. So any tree which has 2 maximum children, we are going to say that it's a binary tree. जबकि any tree which has left child less than node and right child greater than node. This is what is a binary search tree. So this is the simple definition of binary tree and binary search tree. Have I answered you, Atharva, now? Okay, fine. So I move ahead now with again the paper. So show the memory representation of stack using array with the help of a diagram. Okay. So यहाँ पे आपको दिखाना पड़ेगा कि array में exactly data element add कैसे होते हैं, pop out कैसे होते हैं, इस तरह से. Okay. So इन्होंने क्या किया है? They have shown you an array element, okay, of 5 values. Okay. 2000 से लेके if you check A0, A1, A2, A3, A4 इस तरह से इन्होंने 5 एलिमेंट्स यहाँ पे डाल दिए हैं. एनी 5 एलिमेंट्स ऑफ योर चॉइस दे हैव पुट, सो यू कैन पुट इट एज पर योर विश. ओके, एंड ओके एंड इन्होंने यहाँ पे memory locations डाले हैं. So what are these memory locations? See, the memory locations start from 2000, then I am extending it to 2002, 2004. क्यों इस तरह से मैं दो से इंक्रीज कर रही हूँ इसको? बिकॉज ये जो वैल्यूज आपने यहाँ पे डाले हैं ना, दीज आर इंटीजर वैल्यूज, और इंटीजर जो होते हैं वो 2 बाइट्स के होते हैं. इसलिए ये दोनों एड्रेसेस के बीच में आपको डिफरेंस हमेशा 2 बाइट्स का दिखाना पड़ेगा. राइट, आई पुट इट इन दी चैट. इंटीजर साइज 2 bytes. So difference should be of 2 bytes. Okay, so that difference you need to take care. Binary search, okay, I'm explaining the last time. Everyone, please note binary search tree. See, what is a binary search tree? If I have a value over here, okay, when I'm going for the left child, my left side should be less than this node. And whenever I'm going for a right child, my right child should always be greater than it should be greater than that of your node. Okay, if you can remember this, then this is your binary search tree. This is the simple terms binary search tree, right? So please make a note of this. I'll move ahead. Define given two types of graphs with examples. So two types of graphs they have mentioned as a directed graph and undirected graph. I think students in yesterday's video lecture also, okay, you're asking for binary search. Okay, just wait for 2 minutes. Let me finish this, right? So, yesterday's lecture also we have completed what is a directed graph and an undirected graph. I've already explained you with the examples. If you want to go through, you can just visit yesterday's lecture for this question. Okay, so I'll not be explaining this here. I'll explain binary search over here. Binary search also I have explained in the last video, that is yesterday's video. Still I'll be explaining over here. Let's say for a binary search, first of all, important thing is the array should be sorted. So let's say I'll take the array in this way: 10, 20, 30, 40 and 50. And let's say I am telling you search 40. I'm giving you the task of searching 40. Okay, so binary search क्या करता है? It is going to keep some bounds, जैसे lower bound and upper bound. So lower bound will always be pointing to the first element और upper bound क्या होगा? जो सबसे last element को point करेगा. So this is indexing 0, 1, 2, 3, 4. So अगर मैं इसका मिड पॉइंट फाइंड आउट करती हूं तो मिड पॉइंट कैसे फाइंड आउट करना पड़ेगा? मिड इज इक्वल टू L plus U divided by 2. So it is 0 plus 4 divided by 2, which is 2. So आपको 2 लोकेशन पे क्या डेटा है वो फाइंड आउट करना है. So 2 लोकेशन पे आपका क्या डेटा आ रहा है? 30. Okay, now this is, that is A of 2 बोलेंगे हम लोग. A of 2 is 30, which is not equal to 40, क्योंकि मुझे सर्च क्या करना है? 40. So as a result of that, मैं क्या करूंगी? I am going to, I know that 40 is greater than 30. So इसके लिए 40 will always be present on the right of 30 and not on the left. So as a result of that, मैं जो lower bound है, lower bound को increase करूंगी. In this case, my lower bound will become mid plus 1. Okay, so this is your mid. This is going to become mid plus 1. Okay, so now I'm going to say calculation of mid again, which is lower bound plus upper bound divided by 2. अब मेरा mid क्या था? 2. So mid plus 1 क्या हो गया? 3. So 3 plus 4 divided by 2, which is going to give me 3.5. Okay, so if it is 3.5, मैं इसको round up करूंगी 3 से. Now you are going to check the value at A of 3. So A of 3 is giving you 40, which is the answer, and you have got the element. This is what is binary search. Is this understood to you now? Shall I move ahead? Okay, fine. Here, moving ahead, differentiate between, in case of searching 20. Okay, so in case you are searching 20, now जब आप ये step तक it's going to be common. Okay, what you are going to do, आपका जो 20 है, it is less than 30. सो आपको कहां मूव करना है, आपको लेफ्ट डायरेक्शन में मूव करना है. सो आपका लोअर बाउंड 0 रहेगा, बट आपका अपर बाउंड जो होगा इट विल बिकम mid -1. Okay, right? So that is going to be your upper bound, and then again the same procedure follows, right? So you can just make a note of that. Yes, you can round it off, Chetan, to 4 instead of 3. It is okay, completely okay. Only thing is going to be your one more step increases. That's it. Only one step is going to increase, nothing else. You can use 4 instead of 3. That is completely fine, right? Just give me a minute. Okay, please let me know if I'm audible. Okay, fine. So the next question is differentiate between linear and non-linear data structures. Okay, so if you check here, linear and non-linear data structures, I have already covered up in the previous yesterday's video session also. So for further details, you can just watch that video. But just remember, if it is 2 marks, so any two differences, 1 mark each, they are claiming over here. Okay, so they have put 2 differences and they have given 1 example over here. So you can just refer this and do the task, right? Convert the following infix expression to prefix using a stack, right? So this is what is your problem statement. Now if you remember, this same problem we have solved yesterday, right? Lagbhag the same problem we have solved yesterday, where we saw that prefix expression you have to always start from the end. I'll again explain for the newcomers who have joined today. Please check, this is your infix expression and how you are working. For whenever you are going to convert any infix to prefix, आपको क्या करना है, आपको आपका जो इक्वेशन है उसको रिवर्स में रीड करना है, not in a left to right fashion, rather right to left fashion. So just remember, I'm putting it in the chat. Okay, so except Swar, does anybody want me to repeat this? If this is because this is done in the same way it is done yesterday, if you want me to repeat, I'll repeat, otherwise I'll move to the next question. Okay, ठीक है. Okay, so if I do this, now I'm reading the characters from the last. So when I'm saying F, okay, so it's not needed. So in that case, I'll say I'll move to the next question. Okay. Explain the working of binary search with example to students. Right now, I just explained you what is binary search. You can take one small example as I just discussed with you people. So you can just take down that example and that will give you completely 4 marks. So writing the theory will fetch you 2 marks. Then writing an example, any one example of your choice. Just remember that the array has to be sorted. Okay, so you can take any one example of your choice and you can make a note of that. So that is going to give you 2 marks. Okay. Next question. I hope this is clear to all of you. Binary search functionality. If yes, I'll move ahead. Please let me know in the chat. Yeah, if you allow me to finish this summer 2019, then I'll be able to take winter 2019. So that's why I'm asking you, requesting you ki the topics which have been covered yesterday, please go through the video for yesterday. It's available on YouTube. You can go from there and you can visit the things. Okay, so I'll not repeat those things again and again, otherwise we won't be able to complete the next paper, right? Yesterday I had taken in quite detail, so you can just visit those. Write a program to traverse a linked list. So what is traversing a linked list? You have to just move from one end to another of the linked list, right? So if you check here, this is the linked list which we have made, int info. Okay, and what we are saying, enter the value. You are reading the value. Based on that, you are giving control to a function which is known as create list. So create list क्या कर रहा है? It's creating your complete linked list. Remember, this is a 4 marks program. So 4 marks program है, तो आपको with the help of functions ही करना पड़ेगा. Okay, so whenever you are getting create list, this is how you are creating your linked list. उसके बाद यू आर एडिंग एट द बिगिनिंग. सो आप डेटा को ऐड कर रहे हो एट द बिगिनिंग वन बाय वन, राइट? सो एज अ रिजल्ट वेन एवर यू गेट अ फंक्शन void एट बिगिनिंग, राइट? सो आप लोग एक एक करके डेटा को बिगिनिंग में ऐड करते हो यहाँ पे. देन डिस्प्ले. सो द नेक्स्ट फंक्शन इज गोइंग टू बी डिस्प्ले. तो डिस्प्ले पहले क्या करता है? इट्स चेक्स वेदर दी linked list is null or no. If it is null, that means there is no node into the linked list, तो उस चीज को डिलीट किया जाता है, या it's empty, we display it as empty. Otherwise what we do is, in case the linked list is not null, मैं वहां पे मेरा linked list up to the time it's not null, I am displaying the info and next करके मैं next location पे जाती हूँ, right? So this is how I traverse a linked list. You are just displaying the values of a linked list, right? Draw and explain the construction of a circular queue. So circular queue में exactly क्या होता है? Instead of a linear queue, you just have a queue in a circular fashion. So circular fashion में the thing is in this way. आपका क्या होता है? Instead of a first in first out manner, you along with the first in first out manner, the problem is even if your queue is empty from this end, I'm not able to insert, right? So as a result of that, मैं एक circular queue बनाती हूँ जहां पे मैं जब तक वो डेटा 0 के बाजू वाला, that is 7, okay, in a circular fashion, जब तक वो चीज कंप्लीट नहीं हो जाती तब तक I am able to enter the values into the circular linked list. If you check over here, the distribution of marks is in this way, that the diagram is given 1 mark and the explanation over here is completely given 3 marks. So you have to explain what is a circular linked list, what are the benefits of a circular linked list, किस केस में circular linked list use करना चाहिए, etc. I hope these two questions are clear so that I can move ahead. Please let me know in the chat. For circular linked list, maximum they can ask you an algorithm, not a program, because the program is going to be very, very, very difficult at your level. So they will ask you an algorithm maybe for designing of a circular linked list. So वहां पे आपको दो चीजें डालनी पड़ेंगी, insertion into a circular linked list and deletion from a circular linked list. Okay. So moving with the next question, explain in degree, out degree of a graph. This also has been explained in the last paper. If you see, there are many things which are repeated from the previous paper, right? So in degree, out degree has also been explained in the last paper video. So you people can just go through that for the explanation. Write a C program to perform the following operations on array, that is insertion and display. पिछले पेपर में अगर आप देखोगे तो क्वेश्चन क्या था, डिलीट फ्रॉम एन array. तो इस पेपर में क्या आया है, इंसर्शन एंड डिस्प्ले. सो बेसिकली आपका पूरा एरे का प्रोग्राम ही कवर अप हो गया है. सो अगर आपको एग्जाम में अभी कोई भी इन तीनों में से टॉपिक पूछा जाए, सो यू विल बी एबल टू आंसर दिस थिंग, राइट. सो चेक करो, इंसर्शन इनटू एन एरे, सिंपलेस्ट थिंग. You will ask the number of array elements. आपको elements कितने चाहिए. Important questions I'll give at the end of this paper. Okay. So, number of elements into the array. You are going to enter the number of elements. Then you are going to enter the elements, each and every element of that array. So, अगर आप 5 elements बोल रहे हो तो 1, 2, 3, 4, 5 elements आपको डालना पड़ेगा. Then enter the key value and its position. अगर फॉर एग्जाम्पल आपको एरे में बीच में ही कहीं पे डेटा को डालना है, ओके, जैसे सॉरी okay, so if in case you want in this way, you have done 10, 20, 30, 40, size of the array is, एक और स्पेस है आपके पास, these two empty spaces you are having. Now for example, I want to insert, so this is in this way, 0, 1, 2, 3, 4, 5. Okay, this is the size of the array is 6. Now for example, मुझे अभी यहाँ पे insert नहीं करना है, rather मुझे यहाँ पे insert करना है. I want to insert here, but I don't want to delete these elements also. मुझे क्या करना है, I want to create a space in between. Let's say 10, 20, एक space बनेगा, फिर बनेगा 30, 40 and इस तरह से. ओके, सो यहाँ पे आप इंसर्ट कर दोगे और एक वेकेंट स्पेस यहाँ पे मिलेगा. इफ आई वांट टू डू इन दिस वे, सो फर्स्ट व्हाट आई हैव टू डू, आई हैव टू शिफ्ट द एलिमेंट्स फ्रॉम दिस लोकेशन towards the right hand side. Okay, I will be shifting, I'll be writing the algorithm to shift the elements to the right hand side and then insert the element at this location. So same thing has been done over here. If you check, ठीक है. So what is done over here, for I is equal to n, that is that number, I is greater than equal to position and I minus minus, you are going to say ai is equal to a minus 1. So आप next position पे डेटा को डालते जाते हो and वहां पे आपका जो जहां पे you are interested now in putting the data, there you can say a position minus x is equal to x and then you are going to display the complete array using a for loop. So this is what is your insertion and displaying. What is this question? This is 3, right? Okay. Evaluate the following postfix expression. So this is a postfix expression and you are supposed to evaluate this completely. Okay. So how do you evaluate this? Check. I will show it on the screen to all of you. I'll just make a note first what it is. 562 plus into 12, 4 division minus. So here, so if it is this way, 5, 6, 2 plus multiplication 12, 4 division minus. Okay, so stack में कैसे करते हैं? Up to the time you are having some operands, you are going to push. The moment you get an operator, you are going to pop out the 2 elements, do the problem statement and then push it back into the stack. So we'll say here what is the stack and we'll do the operation over here. Okay, so पहला क्या है, 5, so it gets entered under stack. Next is 6, it gets entered under stack. Third is 2, it gets entered under stack. Fourth is plus. So जब plus आ रहा है, you have to pop out the recent 2 elements. तो हमको ये recent 2 elements को pop out करना है, 6 and 2, and then I have to perform this addition. इस पे ये addition करना है. So what is 6 plus 2? It's going to be 8. So you are going to pop push back 8 into the stack. अब क्या आ रहा है? Into. So whenever you are getting into, you have to pop out these two and then do this operation on that. So 5 into 8, you are going to get the answer as 40 and push it back into the stack. Okay. Now next is you have 12. So 12 you are going to enter into the stack. Then you have 4. 4 you are going to enter into the stack. Then you have a division operation. So you are going to say 12 divided by 4. So what is 12 divided by 4? It's going to be 3. So output is going to be 3 because of this division. Okay. और उसके बाद मैं लिखती हूँ minus. So it's going to be 40 minus 3. So your final answer comes out to be 37, which tallies with your answer here, right? So this is how you are supposed to implement a postfix expression using stack. Is this understood to all of you? Please let me know via chat. प्रीफिक्स में होता तो आप स्टैक से सॉल्व नहीं कर सकते वैष्णवी. प्रीफिक्स में कन्वर्ट कर सकते हैं सिर्फ आप स्टैक से, बट प्रीफिक्स का प्रॉब्लम आप सॉल्व नहीं कर सकते थ्रू अ स्टैक. एक्सप्रेशन सॉल्व नहीं हो सकता थ्रू अ स्टैक. Am I clear, Vaishnavi? Okay. So sort the following numbers in ascending order using a quick sort. Okay. Given numbers 52. प्रीफिक्स एक्सप्रेशन को कैसे सॉल्व करना है ये मैंने कल के वीडियो में बताया गया है आर्यन. अगर आप चाहे तो प्लीज वो वीडियो रेफर कर सकते हैं. ओके. सो देयर आई हैव क्लियरली मेंशन्ड हाउ टू सॉल्व अ प्रीफिक्स एक्सप्रेशन. ओके. सो मूविंग अहेड. So this is what is your quick sort. You have to work using quick sort and you are going to find out from here, right? So आप कैसे solve करते हो in a quick sort? Check. You always set a pivot element and the major issue over here is pivot element को हमको एक proper location पे fix करना है. Now this is a quick sort which is 4 marks question, guys. So as a result of that आपको step by step each and every element आपको देखना पड़ेगा. Okay. आपको सिर्फ क्या ट्रैक रखना है, अगर आपने पाइवट एलिमेंट ये 5 लोकेशन को दैट इज ये 39 को सिलेक्ट किया है, सो 39 से कम जो भी एलिमेंट्स होंगे वो सारे लेफ्ट हैंड साइड में होने चाहिए और 39 से हायर जो एलिमेंट्स है वो सारे राइट हैंड साइड में होने चाहिए. दिस केयर इफ यू हैव टू टेक. अगर आप ये कर पाए, so this is going to solve your quick sort completely. So your algorithm also says in the same way. Okay. Since a of j is greater than pivot, do nothing, array will remain same. So अगर आप ये 39 देख रहे हो, आपको सिर्फ ये देखना है कि उससे सब छोटे जो है वो इस बाजू आ जाए और उससे जो ग्रेटर है that come to the right hand side. Okay. So you have to give each and every step over here for quick sort. Okay, the next question is from the following graph, complete the answers. Okay, in degree of node 21. Now I want students to answer in the chat. You have to answer me in the chat what is the in degree of 21 without looking into the answers which is given to you. You tell me what is in degree of 21. Answer me into the chat, everyone. Good. So in degree of node 21 is, in degree means you have to just specify the count students and not the node numbers. You have to just specify the count. So 21 को कितने nodes internally आ रहे हैं check. एक ये आ रहा है, एक ये आ रहा है और एक ये आ रहा है. It's coming from 19, it's coming from 1, it's coming from 7, right? So इसलिए इसका in degree क्या हो गया 3, right? Adjacent node of 19. What is the adjacent node of 19, everyone? Please do not look into the answers. Just let me know. Adjacent node of 19. One and 21. Any other answer? Two? No. How can two be? 1 and 21. Why you are saying 1 and 21, students? Because from 19 you can go to only two nodes. That's why we call them as adjacent nodes, right? मैं 19 से दो जगह जा सकती हूँ, मैं 1 पे जा सकती हूँ, मैं 21 पे जा सकती हूँ, right? So as a result I say these two are adjacent nodes, which is correct. Now tell me what is path of 31? Path of 31. आप कैसे 31 तक आ सकते हो? Can you please let me know in the chat? There are different paths. I'll directly move with the answer if required. Check. There are different paths. I can come from 1, 21, 31. I can come from 1, 7, 21, 31. I can also, this is my third path is also 1, 7. They have repeated it, I think, right? It's 1, 7, 21, 31. It can be 1, 21, 31, 1, 7, 21, 31. It can be in this way, 1, 12, 19, 21, 31, right? So I am writing it in the chat, everyone. The third possibility, which I think there is a printing mistake. So it's 1, 12, 19, 21, 31. Okay, so this can be one of your path. What is successor node of 67? अभी मैंने स्टार्ट में आप लोग को बताया what is successor. Successor means child. 67 का कोई child है? नहीं है. So that's why we are going to see successor since it is isolated node and not connected. इसका कोई child है ही नहीं. It's anyways isolated. ये कहीं पे connected भी नहीं है. So that's why हम बोलेंगे कि इसका कोई भी successor नहीं है. I hope this question is clear to all of you. If this is clear, please let me know whether I can move ahead or no. Okay, so moving with the next question, differentiate between binary search and sequential search, that is a linear search. This question also I have solved in yesterday's video. Yesterday's paper also you had a question in similar way. So I have already said I'll give you important questions at the end. Okay, I cannot give you important questions now. I have to at least complete this paper. Then only I can give you the important questions, right? So kindly hold on for a few more minutes. Okay. So binary search and sequential search. So you have to just find out what is the difference. So it's a 4 marks question. So you have to give 4 valid points, right? Draw the tree structure of following expressions. Now I've just explained you what's an expression tree. So you can just refer that topic and you can draw these trees now. Okay, so you can just go for development of these trees using the concept which I just explained you. Create a single linked list using data fields in this way. Search a node 22 from the single linked list and show the procedure. So you are going to create a linked list, simple linked list इस तरह बनेगा आपका. You know how to create a linked list. So 15, 20, 22, 58 इस तरह से. 60 is the last नंबर इनटू द लिंक लिस्ट. तो इसके लिए हम उसका नेक्स्ट एड्रेस जो है वो नल कर देते हैं. ओके. अब मुझे अगर 22 सर्च करनी है तो आप कैसे सर्च करेंगे? आप यहां से स्टार्ट करेंगे, पहले नोड से स्टार्ट करेंगे और आपको देखना है कि if it is null, so you are going to say that your linked list is empty. Otherwise, is this the element which you are looking for? If it is 15, we are looking for 22. So we are going to say, is it 22? We say no. So move to the next node. Is this 22? No. So we move to the next node. Is this 22? Yes. So we stop our search here and we display this, right? So you have to simply write down the algorithm over here for the same. Evaluate the following prefix expression. Show diagrammatically each step of evaluation. So now using this, remember what you have to do. अगर आपको prefix expression आता है, you may be getting confused with how to solve. आपको एक simple logic follow करना है. इसको उल्टा solve कर दो. इसको अगर उल्टा solve करोगे, so you can solve it in the way you solve postfix expressions also. Okay. So आपका क्या आता है? 5, फिर 5 2, फिर 5 2 3, 5 2 3 4. अब आपका इक्वेशन आता है प्लस. जैसे ही आपका प्लस इक्वेशन आता है, आप क्या करते हो? टॉप मोस्ट दो एलिमेंट जो होंगे उनके ऊपर वो इक्वेशन रन करते हो. सो इट्स 3 and 4. सो 3 and 4 के ऊपर इक्वेशन रन करोगे 12. एक्चुअली दिस इज नॉट द करेक्ट वे, दिस इज द रॉन्ग वे. बट द ओनली थिंग इज की फॉर स्टूडेंट्स टू मेक इट इजियर, दे हैव मेड वेज इन दिस वे दैट यू कैन मूव इन अ I mean right to left direction and you can solve it. Okay. Actually आपका stack कभी भी right to left direction में नहीं जाता, वो हमेशा left to right जाता है. That's why solving a prefix expression using a stack is a real challenge. But since आपका syllabus में वैसा included नहीं है, so we'll just stick to what your syllabus says. So what we are going to do, we are going to go in a reverse way. So 5 2 3 4, जैसे ही 3 and 4 मिला, इसके ऊपर you are asked to do the एडिशन, राइट? अब एडिशन में यहां पे मिस्टेक हुआ है, चेक. ये 4 and 3 के ऊपर यू आर सपोज टू गो फॉर एडिशन, सो यहां पे 7 होना चाहिए था. इट्स गिविंग यू 12, विच इज रॉन्ग आंसर. Okay, so 4 plus 3 should give you 7 and 7 should get entered into your stack. उसके बाद आता है multiplication. So आप 2 into 7 करोगे, that's going to give you 14. Yes, answer wrong है आपका. Okay, so 2 into 7 जो है वो आपको मिलेगा 14. Okay, so 5 and 14 आपको मिलेगा. और उसके बाद आपका, yes, it's a printing mistake, right? So यहाँ पे जो आपका 14 आएगा, then you are going to say minus. So आप लोग क्या करोगे? वो 14 में से you are going to deduct 5. So 14 में से जब आप 5 डिडक्ट करते हो, नहीं, आंसर should not be 19. I think 14 minus 5 should give you 11. The answer should be 14 minus 5 should give you 9. Sorry, the answer should be 9. That should be the correct answer, right? So please note this. Correct. So that is the mistake done. I'll put it in the chat, everyone. 4 plus 3, sorry. पहले आपको 4 plus 3 करना है. Okay. उसके बाद the output will be 7. तो उसके बाद you are going to say 7 into 2, which is going to give you 14, and then what you're going to say, 14 minus 5, which will give you the final answer as 9. So this should be the correct format. Okay, so please correct it, students. If you have a print with you, you can please correct it. Write an algorithm to delete a node from the beginning of a circular linked list. Okay, so in the last class we have seen delete a node from the linear linked list. Now here we are seeing delete a node from the circular linked list. So you are supposed to go on the same track. Okay, सिर्फ आपको ये याद रखना है कि ये जो लिंक लिस्ट आप बना रहे हो, दिस इज अ सर्कुलर लिंक लिस्ट. सो कुछ उसके स्पेसिफिक टेक्निकलिटीज होंगे, आपको वो टेक्निकलिटीज डाल के ये लिंक लिस्ट बनानी है। सो यहाँ पे आपको डिलीट एट द बिगिनिंग करना है, राइट। सो डिलीट एट द बिगिनिंग, आपको सबसे पहले एक सर्कुलर लिंक लिस्ट बनाना है, देन आपको देखना है कि उसका फर्स्ट नोड एक्टिव है या नहीं। अगर उसका फर्स्ट नोड एक्टिव है, सो यू आर गोइंग टू डिलीट इट। तो उसके लिए आप क्या करेंगे, चेक अगर ये आपका सर्कुलर लिंक लिस्ट है, लेट्स से आई एम राइटिंग ओवर हियर 12, 13, 14, 15, 16, okay, this is your circular link list, right? If I want to delete this from the beginning, so what I have to simply do is इसको मुझे free करना है। So what I have to do, this last nodes next will be, ये start है, this is start next, this 13 is start next। what you are going to do, this next you are going to link with this 13। if you are linking with this and then you are writing a code to free this 12, ऑटोमेटिकली आपका फर्स्ट नोड यहां से निकल जाता है एंड यू आर गोइंग टू लिंक दिस विथ दिस। सो दिस इज हाउ वी राइट डाउन अ कोड और एन एल्गोरिथम टू delete the first node from a circular linked list. Okay. Next, you are supposed to show the operations of push and pop into a given stack. So your stack you have to fully complete. Okay. So when it says 50 is at the top, so आपको इस तरह लिखना है 40, 30 जिस तरह से है। Now they are saying push, so you are going to push 59, push next element 85, then you are going to pop, so एक element निकल गया stack top। You have to always note what is the condition of stack top। आपको बार बार stack top क्या है वो लिखना पड़ेगा। ओके, stack top अगर नहीं लिखेंगे तो आपके मार्क्स यहाँ पे कट होंगे, क्योंकि सिर्फ आप push and pop करेंगे तो वो क्लैरिटी नहीं आती है। जब आपको stack top लिखते हो तब आपको वो क्लैरिटी आती है, राइट। Right, moving ahead now. This is traversing the in order, pre-order and post-order methods. Okay. Now pre-order, post-order, everybody please concentrate here. This I had already solved in the last class, that is yesterday's video. But again, since few people had a doubt, so I'll repeat here. But I want everybody to please concentrate here. Okay. Now, if you check, this is your complete tree. In order में हम लोग क्या करते हैं, we first go to the left tree, then to the root and then to the right tree, right? So हम लोग क्या करेंगे, सबसे पहले एकदम लेफ्ट से चालू करेंगे। Okay, Ninad, I'll explain quick sort. Just hold on, right? So we'll begin here. So let's say this is 1. So I begin with the left hand side 1. So this is your left, then vertex, then right. So it's 1, 10, 15. Left subtree done. Then I go with the vertex, that is 20, and then with the right, that is 22. Left tree done. Then you go for 25 and then 32. Okay. This is the case. Now when you are going to 36. Okay. तो ये आपका main vertex cover होता है। Now again when you go to the right subtree, आपको left से start करना है। तो पहला left क्या है, 43, फिर 48, फिर यहाँ पे right है, लेकिन right का भी एक left है। So that's why you are going to go for 50, 56, फिर से ये right है, ये right side का भी एक खुद का left है। So you are going to have 58, 60 and then 75. This is what is in order traversal. Pre-order traversal is you're first going to write down what is the vertex, then the left and then the right. So इसलिए आपका शुरू होता है vertex 36, उसके बाद left subtree शुरू होगी 25, उसका left 20, उसका left 10, उसका left 1, सब left cover हो गया। अब आप right पे जाओगे। ओके, सो अब आप जाओगे 15, उसके बाद आप जाओगे 22, उसके बाद आप जाओगे 32। ओके, then you will move to the right hand side, so you go for 48। ओके, उसके बाद you have a left side 43, then 56, 50, then 60, 58, and then finally 75. So it will always be vertex, left and right. That process you have to follow for pre-order traversals. Post-order traversals is left, right, then vertex. So I go for 1, uske baad we are going for 15, then we are going for 10. I'll just reduce this slightly. Okay, so I go for 1, then I go for 15, then for 10, then again 22, 20, 32, 25. Okay, is tarah se. Then you don't go for this vertex, you go for the right hand side. So right hand side is 43, then you go for 50, right? Then you are going for 58. उसके बाद आप जाओगे right side पे, so that is 75. उसके बाद आप जाओगे vertex पे 60, 56, 48, and then you will come to the final vertex. Okay, so this is how we go for in order, pre-order, and post-order methods. Right? Write an algorithm to count the number of nodes in the singly linked list. So this we have already solved in yesterday's video. I request you to go through the yesterday's video for this answer. Sort the following numbers in ascending order using bubble sort. So this sorting, bubble sort, I have explained in the previous video also, yesterday's video. You can just go for, वहाँ पे भी एक example था. I have explained in detail how to work with bubble sort. You can just run out this example on that. And this is evaluation of the postfix expression. तो इसी पेपर में एक postfix expression हमने evaluate किया using stack. Same thing यहाँ पे evaluated है. आप लोग आपका खुद से check कर सकते हैं how this answer has come. Okay, and single linked list using data field. So you can just create a single linked list over here and search a node 40. तो इसी पेपर में एक previous problem था जहाँ पे हमने search node 22 किया था, right? Same way आपको search node 40 करना है, but यहाँ पे अगर आप देखेंगे, so यहाँ पे अगर आप देखेंगे तो यहाँ पे you do not have the node 40, right? So आपके पास node 40 नहीं है, so you are going to have 90, then move to 25, then move to 46, then move to 39, and then move to 56. The moment you see here you do not have 40 node, you say that from the linked list I am not able to find out the data, right? So this is what is your searching a node. But the only thing is कि you have to write a stepwise program over here, right? आपको stepwise लिखना पड़ेगा ये पूरा program, right? क्योंकि you have 6 marks, so हर एक point के लिए, हर एक step के लिए आपको एक mark मिलेगा. Okay, so I hope this is completely understood to all of you. If yes, I'll move to quick sort, everyone. Please let me know whether this is understood or no. Okay, now I'll quickly take you to quick sort. I will not be able to explain you in detail what is a quick sort. For that, I will request that we have YouTube videos from V2V classes in, yeah, sorry, I forgot to give you the important questions. I'll again just move on with that, right? So we have V2V classes. In classes, we have the video lectures which have been recorded for all these topics. So for quick sort also I have done video lectures. If needed, you can just go through those lectures. They are available on YouTube, right? Because I won't be able to explain that entire thing here in detail. Okay, so I'll just move here. Let's say I have some 10, 50, 30, 60 and 20. I'll say in this way. Okay, so in quick sort, what we do exactly is we select one pivot element, any one pivot element. Okay, from this pivot element, what we exactly do is, yeah, वही बता रही हूं मैं कैसे sort करना है, कि ये जो pivot element है, ये pivot element को आपको ऐसे जगह पे fix करना है कि इसके पहले जो भी numbers आएंगे वो सारे इस pivot से छोटे होंगे. और इसके बाद जो भी नंबर्स आएंगे वो सारे इससे बड़े होंगे। आपको कैसे स्टार्ट करना है, यहाँ पे एक काउंटर रखना है, यहाँ पे एक काउंटर रखना है। दिस इज द लेफ्ट काउंटर, ये हो जाएगा आपका राइट काउंटर। ओके, यहाँ पे अगर आप काउंटर्स रखेंगे, सो व्हाट वी आर गोइंग टू डू, लेफ्ट, if this is I mean, if this is less than 30, you compare it with the pivot. This is less than 30. Okay, that means it's in the correct place. You move here to 50. Is this less than 30? No. So you stop here itself. Don't go ahead. 20, is it less than? It has to be greater than. This side means it has to be greater than. 20, is it greater than 30? No. So your right will be here. So what you are going to do? You are just going to swap left with right. So आपका 20 इधर आ जाएगा, 50 इस लोकेशन पे आ जाएगा। अब आप आगे जाओ, लेफ्ट, इज 20 लेस देन 30? यस, सो मूव अहेड, यहां से मूव अहेड करो। यू हैव रीच द पायलट, तो आपको यहां पे रुकना है। ये आपका 50 है, ओके, इज 50 ग्रेटर देन 30? यस, मूव एट दिस साइड। इज 60 ग्रेटर देन 30? यस, मूव एट दिस साइड। 30 is equal to 30. When your left and right are at the same position, you can say that I have fixed the pilot element. So मेरा जो pilot element है उसको मैंने fix कर दिया है। 30 के आगे जो भी elements है, check it is less than 30. 30 के बाद जो भी elements है, they are greater than 30. Only thing is कि this may not be sorted, students. ये sorted नहीं भी हो सकता है, ये sorted नहीं भी हो सकता है, that's completely fine. तब आपको क्या करना पड़ेगा, ये 10 20 सॉर्टेड है, 10 20 30 सॉर्टेड है, आपको अभी 60 को पाइवट कंसिडर करना पड़ेगा और आपको रीरन करना पड़ेगा आपका ये एल्गोरिदम। इज दिस नाउ अंडरस्टूड निनाद? Okay, so I will move on to the important questions of this paper before I go for the next one. Check everyone. This type of problems, convert infix to prefix. This type of problems can be important. Write a program to traverse a linked list. This can be important. Then a C program for operations on an array. That can be important. Expression trees can be important. Yeah, that's it from this paper. Ninad, how can you bring 50 back? Why cannot we bring 50 back over here? Check. चेक, 50 क्यों नहीं वापस आ सकता? अगर आपने अभी 60 को पाइवट एलिमेंट कंसिडर किया तो 60 के पहले, 60 के राइट लेफ्ट साइड में, 60 के लेफ्ट साइड में यू शुड हैव एलिमेंट्स लेस देन 60. सो आप जैसे ही, एंड राइट साइड में इट शुड बी ग्रेटर देन 60, राइट? सो आप जैसे ही 50 को देखोगे, इसलिए 50 लेस देन 60, यस, इसको यहां पे मूव कर दोगे ना आप, यू आर गोइंग टू मूव इट हियर. 60 लास्ट में चला गया, ये ऑटोमेटिकली सॉर्ट हो गया। देखो 10 20 30 50 60 डायरेक्टली, उतना ही करना है आपको सिर्फ, राइट? जो भी सॉर्टेड नहीं है उसको पाइवट पकड़ो और उसको सही जगह पे लगाने का कोशिश करो, राइट? आई होप दिस इज क्लियर नाउ. Okay, students, I'll move to the last paper now. Okay, slightly faster. Okay, So operations which can be performed on data structure, we just now saw in the previous paper, right? So you can do this, right? Explain the term overflow and underflow with respect to stack. We have explained this yesterday also in the yesterday's video. I'll request everyone to please uh, go through that video, right? So explain the term overflow and underflow. Simply, when your stack is completely full and you are trying to insert something into the stack, that is an overflow condition. And when your stack is empty and you're trying to delete something from the stack, that's an overflow condition. Sorry, underflow condition. You can just make a note of that. Okay. Then again, in degree and out degree, which is hell many times repeated. You can just go through that. Evaluate the expression using postfix notation. We have done 2 or 3 problems in the previous. Students, am I audible now? Please let me know. Am I audible? Please let me know whether I am audible. Okay, fine students. So I'll start again. Check. I was just talking. Question number 1D you were saying, right? So 1D, prefix to prefix notations, how to evaluate. We have already seen many problems in our previous 2 papers. So you can just refer those two papers and go through. Describe the directed as well as the undirected graph. Describe the directed and undirected graph. So this also we have referred in many papers, so you can go through. And this define Q, we have covered it in last lecture only. So you can just refer those because these are theory questions. I'll move on to radix sort. So radix sort, if you know, radix sort is you are going to sort on the basis of the LSB. So if we have these numbers, you are going to first sort on the basis of the LSB, that is 8, 4, 1, 1 and 4. So based on that, you are placing the elements. Then you are going to sort on the middle element and then on the last element, right? So this is how you are going to sort. So that is what is completely a radix sort. So you can just check out the working over here. I hope radix sort up to radix sort is clear to all of you. Please let me know. Okay, fine. So we'll move ahead. Algorithm to insert a new node at the beginning of singly linked list. This was completed in yesterday's video lecture only. So you can just go through that. Because we have covered up all these things yesterday in detail. So I'm not going now in details. Concept of circular queue along with its need, we just completed in our previous paper, right? So you can just look into that. Binary search tree for the given number. How to design a binary search tree, we have already seen in yesterday's class, right? Yesterday I had explained you how to design a binary search tree in detail, so you can go there. Explain time and space complexity with the help of an example. Now what is this time and space complexity? Now time complexity will tell you how much time it requires to execute a program, right? That is what is a time complexity. Space complexity is how much space it requires for execution of your program, right? So that is what is your time complexity as well as space complexity. So you can just write down slightly in brief regarding the same. Infix to postfix expression, we have done many times in the previous papers, so we can wind up that things. C program using linear search, okay? So this also C program for a linear search we have done in yesterday's video. You can just run through that. Expression tree we just completed today. Binary search method also we have completed today itself. Difference between a tree and a graph. This is a repeated question from yesterday's paper. So yesterday we have discussed with examples how to differentiate between a tree and a graph. You can just go through them. Construction of a single linked list. We have seen 2 examples in the previous paper itself, that is today. Push and pop. अभी इसके पहले वाले पेपर में हमने देखा है पुश एंड पॉप कैसे करना है एंड टॉप कैसे उसका डिफाइन करना है. Compare linked list and an array. So what is basically the difference between a linked list and an array? Okay. So array क्या होता है? It is consecutive memory locations. जबकि linked list क्या होता है? It's not a consecutive memory location. So there are 4 marks. So 1 mark for each point. Okay. So आप array को कैसे access करते हो? आप linked list को कैसे access करते हो? You need to specify it in that way, right? So those things. एक होता है स्टैटिक मेमोरी, एक होता है डायनामिक मेमोरी. सो दैट यू कैन डू. Insert element into queue and delete an element of the queue. This is a repeated question from yesterday's paper. Yesterday हम लोगों ने ये solve किया है. Go through that. Consider the graph given in following figure. Answer the questions. All path from 1 to 5. You can at least answer with this, students. In degree and out degree of 4. आप मुझे at least ये आंसर कर सकते हो. In degree and out degree. बता सकते हो इन डिग्री एंड आउट डिग्री ऑफ 4 क्या है? प्लीज लेट मी नो इन द चैट. इन डिग्री एंड आउट डिग्री कितना है बताओ? In degree is 1 and out degree is 0. आउट डिग्री जीरो क्यों होगा? बिकॉज देर आर नो आउटगोइंग लिंक्स फ्रॉम हियर, सो आउट डिग्री इसका जीरो होगा. गुड. एडजेसेंसी मैट्रिक्स एंड एडजेसेंसी लिस्ट मैंने कल के वीडियो लेक्चर में एक्सप्लेन किया है, यू कैन गो थ्रू दैट. Algorithm to search a particular node in given linked list, this is explained in yesterday's video lecture in detail because these questions are repeated from that paper only. Elaborate the steps of selection sort. Selection sort I have explained yesterday only. Yesterday's paper, same values have been repeated in this paper also. There are no change in values also. So you can just refer from there. Recursion using a stack has been explained yesterday also. And factorial is the program which was explained yesterday. So you can go through that. Delete a node from a singly linked list. ये हमने आज के पेपर में ही डिस्कस किया है. एंड ये इनफैक्ट कल के पेपर में भी यही लास्ट क्वेश्चन था. Delete a node from singly linked list from start, from between as well as from end. And this completes all the questions of winter 19. Okay, so I will give you the important questions from this paper also. Make a note, everyone. Radix sort, you can go through radix sort. Concept of circular queue. Building a binary search tree. Time and space complexity. Question number 6B. Okay, I'll check. Yeah, 6B has been explained in yesterday's video only. What is recursion? I have explained the factorial program in detail. I'm requesting you to please go through yesterday's video lecture. There you are going to get an explanation completely for this, right? And this question, single linked list, beginning, in between and end of list. ये एक देख सकते हो. These are the important questions from this paper. So I hope I have made all my points clear. I have solved all the 3 papers as promised. Okay. And mostly what हम लोग को क्या दिखाई दे रहा है यहाँ पे कि डेटा स्ट्रक्चर का पेपर में क्वेश्चंस बार बार रिपीट होते हैं. ओके, सो ये जब बार बार रिपीट हो रहे हैं, सो आई विल रिक्वेस्ट यू कि जो क्वेश्चंस यहाँ पे है प्लीज डू नॉट लीव देम इन ऑप्शंस. ये पढ़ के जाओ क्योंकि 90% पेपर इसी में से रिपीट होने वाला है. मे बी 10% यहाँ वहां से पेपर से क्वेश्चंस आए. कल आपका पेपर है, सो ये 3 पेपर्स से भी अगर आप अच्छे से प्रिपरेशन करके जाओगे, सो आई गारंटी यू विल गेट अबाउट 70 एटलीस्ट इन डेटा स्ट्रक्चर्स. ओके, सो प्रिपेयर योरसेल्व्स वेरी वेल एंड डोंट टेक टेंशन and write the answers to the points and always see the marks, and based on that you please try and write down the answers. Okay, if any questions from your side, please let me know. Otherwise we will wind up for the day. All the best to all of you and thank you very much for being online. समर एंड विंटर का पूरा मैंने बता दिया है. इंपॉर्टेंट क्वेश्चंस समर का भी बताया है, विंटर का भी इंपॉर्टेंट क्वेश्चन बता दिया है, और कल का जो पेपर सॉल्व किया था उसका भी इंपॉर्टेंट क्वेश्चन बता दिया है मैंने. यू कैन जस्ट रिवाइंड द वीडियो एंड यू कैन सी. ओके, any more questions everyone? In order, pre-order, post-order, I have repeated in yesterday's class. Also, I have repeated in today's class. Okay, same example I have taken twice. You can please go through both the videos and you can go, otherwise you can just register for the course. Maybe I have taken one entire video on pre-order, in order and post-order, right? So I have explained in yesterday's video also, in today's also. You can just go through that, right? Thank you everyone.